Okay, Jerry, we're going on. They're live in 5, 4, 3, 2.
Okay, hello everyone and welcome back. We are continuing our special series dealing with water erosion, and today we'll be discussing the causes and effects of water erosion. To help us find out more about the causes and effects of water erosion, I have with me in the studio Associate Professor Saskia Keistra. She's an expert in soil erosion processes in the Soil Physics and Land Management Group here at Wageningen University. So please join me in welcoming Dr. Saskia Keistra. Great to see you.
Great to see you too.
Saskia, for the benefit of our viewers from all over the world, can you tell us a little bit about yourself?
Of course. Well, I'm a physical geographer from background. I studied hydrology and quaternary geology and became more and more interested in the movement of water and sediment in catchment systems. And in addition to that, I also work a lot on the dissemination of the science that I work in towards other disciplines and also to the general public.
Great. Look, today we'd like to talk to you about the causes and effects of water erosion. And many of our viewers have posted messages, emails, sent us SMSs and posted messages on Facebook. Keen to know more about what these causes and effects are. Can you please give us an overview of what's going on?
Yeah, for this I would like to use the following diagram in which I can explain what I mean with catchment system dynamics. I view this as a system in which processes and feedbacks interact. And the system in terms of water and sediment movement within that is impacted by natural and human drivers. So you have natural drivers such as a wildfire or climate change or land cover changes, or human drivers such as catchment management, so land and water management. And if you understand how the process and feedbacks within such a system work, then you can also know what the consequences of such drivers would be. So, for instance, how much sediment it will be accumulating downstream or how much water will be available for crop growth. And if you then really fully understand how the processes interact with these drivers, then you can also try to manipulate using specific management strategies to come to a sustainable situation.
That's great. Look, Saskia, I've also heard that when it comes to catchment processes, we're talking about a balancing act. Could you please explain exactly what that means?
Yeah, I will try that. I want to use for that this diagram from Professor Lane, which was introduced already in 1955. So it's a very old diagram, but I still think it clearly shows how water and sediment interact with each other within a catchment system. So you have, on the one end of the balance, you have the amount of water, and on the other end of the balance you have the amount of sediment and the size of the sediment. And on the side of the water you also have the slope of the stream. So what happens, for instance, if your system always tries to be in an equilibrium, and what happens when your system comes in disequilibrium, for instance by climate change, you get less water available because the rainfall decreases, then your this end of the balance becomes lighter, and this arrow will then go this way, and your system in the river will aggrade. So more sediment will be depositing there. On the other hand, you can, for instance, have a situation in which you have less sediment available, for instance, because of reforestation, because the amount of sediment coming from your hill slopes will decrease. This means then that this part of your balance will become lighter and your system will degrade in your river system.
That's great, Saskia. So I was going to ask you, what he's saying is that imbalances within a catchment can be reflected in the changing sediments within the catchment. Is that correct?
Yes.
Okay. So can you now tell us more about some examples, provide some examples of some of the causes of these imbalances, especially in relation to water erosion?
Yes, of course. Well, one of the key drivers drivers that are very clearly to be seen in a natural system is a wildfire. If a wildfire occurs, your system basically becomes an outdoor laboratory. All your vegetation is gone, and therefore the availability of your sediment will be much higher. So you will have a lot of accumulation of sediment in the base. And off-site effects of this situation will be quite fierce. You can see here on this picture, you can see the sediment accumulation here in the base, which does not only involve sediment, but also other types of debris. Also, climate change can have such an impact, either by creating droughts or creating floods, so much more off-site water availability. Also, then you have also agricultural management or land management has a big influence on the on the balance between water and sediment. It basically always boils down to whether you have the availability of your sediment to be moved and the amount of water that has the capability to move the sediment. So if you're, for instance, in an agricultural management system, have a cover crop in between your vines, as in this vineyard is shown, then the availability of your sediment will be less. If you, in this next slide, see that you're plowing your field, this means that the availability of your sediment will be much higher, but also the roughness of your system will be much higher. So again, that has an impact on the balance between the available sediment to be transported and the capacity of the water to transport it. And this then goes to what kind of impact does that have on the on-site, such as you can see here. You can see a completely bare apricot orchard somewhere in Spain. And you can see that because of its bareness, the rainfall has the capacity to move the sediment, creating these huge rills. And then this sediment, of course, will be moved downstream, creating a problem off-site. So like here, you can see that the sediment is accumulating in the ditch next to in the drainage ditch next to the road, creating a big financial problem because, of course, this sediment needs to be removed, and that is very costly.
That's great. Saskia, do you have any specific examples of showing water erosion or different types of soil erosion within the same area?
Yes, I have a very good example for that, and you can see here a field, which is a farm field near to Tel Aviv, and this was a rainfall event of about 300 millimeters in 2 days, which is a huge amount of water for such a short time. And the farmer on this field decided to plow and prepare his field for seeding 1 day before this event happened, creating a situation in which the sediment was very erodible. The sediment was very ready to be detached and to be moved, and therefore he created this huge gully system on his field. However, if you look at this field a little bit further away, you see that there is no gullies and there's no big rills. While this field is on a similar slope, it has similar soil, and it received, of course, the same amount of rainfall, and nothing happened. So, and the only difference between these two fields is the way they were managed.
Fantastic. Look, can I thank you for making time today, for talking to us and sharing your wisdom amongst everyone out there listening. So can you please all join me in thanking Saskia today? Thank you very much.
You're welcome. My pleasure.
Okay, so in conclusion, the take-home message today is that thinking about the whole catchment and the processes that operate within it is crucial for managing the impacts of water erosion and ensuring soil for life. Thanks for watching, and until next time, this is Jerry Moroz signing off. Bye.